Welcome to EDU World Space.
Question number 143. We can divide the element into three parts, so the mass amount of inertia of the whole element can be written as Ix equal Ix1 plus Ix2 minus Ix3. This is equation number 1. Okay. In order to determine the mass moment of inertia, we will need to determine the density of steel, which is equal rho equal gamma over g. By substituting its value, we can reach that 490 pound per feet cube over 32.2 feet per second squared equal 15.217 pounds multiplied second squared per feet power 4. Since all our moments of inertia are calculated in inches, we will convert the density to rho equal 1 over 12 power 4 multiply 15.217, so it's equal 7.339 pounds second squared per inch power 4. The mass of part 1 is m1 equal rho v1 equal 3.6 multiply 12. Sorry. Okay. 3.6 multiply 1.2 multiply 6 multiply 7.339 multiply 10 power negative 4, which is equal 19.022 multiply 10 power negative 3 pounds second squared per inch. Sorry. No, it's okay. So using figure 928, the mass moment of inertia about centroidal x-axis is I x bar equal 19.022 multiply 10 power negative 3 over 12 multiply 1.2 squared plus 6 squared equal 0.05936 pounds second squared inch. Since the distance between centroid of part 1 and x-axis is d equals 3 inch, the mass moment of inertia about x-axis is Ix1 equal Ix bar plus d squared m equal 0.05936 36 plus 3 squared multiply 19.022 multiply 10 power negative 3. So ix1 equal 0.23056 pounds second squared inch. The mass of part 2 is m2 equal v2 rho equal half multiply 1.8 squared multiply 1.6 multiply 7.339 multiply 10 power negative 4. So it's equal 5.976 multiply 10 power negative 3 pounds second squared inch per inch. Sorry. Oops. Per inch. Okay, using symmetry, the mass moment of inertia of half cylinder is equal to half of the mass moments of full cylinder, which is actually the ratio of the masses. So using the figure 9.28, the mass moment of half cylinders about x dash axis is ix dash equal 5.976 multiply 10 power negative 3 over 12 multiply 3 3 multiply 1.8 squared plus 1.6 squared equal 0.00611 pound second squared inch. The distance between centroid C2 and x dash axis is d equal 4 multiply 1.8 oops over 3 by equal 4.764 inch. So the mass moment of inertia of half cylinder above centroidal x-axis is ix2 bar equal ix dash minus 0.764 squared m2. The distance between centroid C2 and x-axis squared is d2 squared equal 5.2 squared plus 0.6 plus 0.764 squared equal 28 point sorry 0.9 inch squared. So the mass moment of inertia about x-axis of part 2 is ix2 equal ix dash plus 28.9 minus 0.764 squared m2. So it's equal 0.00611 plus 28.9 minus 0.764 squared multiply 5.976 multiply 10 power negative 3, which is equal 0.17533 pound second squared inch. The mass of part 3 is m3 equal v3 rho equal 1.5 squared by multiply 1.2 multiply 7.339 multiply 10 power negative 4 equal 6.225 multiply 10 power negative 3 pounds second squared per inch. Using figure 9.28, the mass moment of inertia about centroidal x-axis is ix bar equal 6.225 multiply 10 power negative 3